Oh, good. Yeah, welcome back to a session with your friend Edu Ada. Oh, please kindly subscribe to my channel, watch the videos, share with friends, especially the Waec and Neco student taking exams now. Share these videos with them. But kindly subscribe, like, and make your comments. Today, we'll be talking about statistical graphs, and under this we're dealing with the construction or the use of histogram to estimate your mean and your median from any given distribution. So we have this question. I'll draw the histogram of the distribution to calculate correct to the nearest whole number the median and the mode. So we have this distribution given here, and I've tried to carry out or to solve out the things that will be needed. Now, let me take you through some things. When you are constructing an histogram, don't forget from the primary or from a lower class knowledge, you will be told that the histogram they actually join together, unlike the bar charts. So you have this, 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 this. So we are dealing with something like this. But to achieve this, we need the marks. We have been given the marks in the question. We should have said, okay, let's make use of the class mark, but we don't need it here. So what we need basically, it's along the x-axis, we need the class boundary, and along the y-axis, we need the frequency. This is for histogram distribution. I think after this we'll talk about the cumulative frequency curve, and there we're making use of our uh, cumulative frequency with respect to only the upper class boundary. But here let's come back to the histogram distribution. So here we just use the class boundary at the x-axis. Then on the y-axis, you use a frequency, that is the frequency. Yeah, here we have the CB class boundary. Of course, you need to take note of your class size between 0 to 9, 10, 10 to 11, 10 to 19, equally 10, yes, 10, 10. But I have the last one, we have it to be, let me confirm this. So you have 10, 10, yes, that should be 20. 39.5 to this is 20. It is a bit bigger, so I will make this correction now. Please follow up with me as I do these solutions. So I have this to be 20. Then how do I come about my class boundaries? All you have to do is look at your class mark. This column, look at this column. You have 0 to 9, right? Ideally we should have just done is 0, okay? Should have just done this minus 0.5, then to this 9.5, oh 9, 9 plus 0.5. So that will give me minus 0.5 to 9.5. But that the class size still remains 10, and the subsequent or the next class boundary from 10 to 9, subtract 0.5 from 10, you have what? 9.5, 9.5 to We have 19, that will be 19.5. So get the idea behind that. The lower class mark, you subtract 0.5 from it. The higher class mark, you add 0.5 to it. So the next one you're going to be having subtract 0.5 from 30, you have 29.5. 29.5. Then 2, you have 39.5. On and on till you exhaust the class mark, which is the last one, 39.5 to 59.5. And this is what we'll be using with our frequency, which has been given in the question. So let's go ahead to answer this question. Now, constructing this, the real graph, with the use of the information we have as a class boundary and the frequency, how will it look like? This might not exactly be perfect, but we follow the instructions given, you will get a perfect result, even just like when you use your calculations. So quickly, let me have this, have this. Okay, I think a bit tense. So I have this. I'm sorry that I had to use 3 minutes to get this done. So I'm having this. Follow me, please. Yes. So that will be my for my y-axis. Then I maintain this again for my x-axis. More will maintain this. Okay, coming. I want something lower. I want the line should be okay. Okay, so maintain this. So I have this. Keep moving. I'm not using a ruler, so that I have exactly perfect line. So yours will be exactly. So here now, for the first information, the first bar, 0 to 9. Now let me, for my frequency, which is supposed to be on the y-axis, let me take each of these boxes. I'm taking it to be 5 centimeter, or I take it to be 2.5 centimeter, 2.5 centimeter. So 2 boxes, 5 centimeter, 3, 15. Then this 5, 10. So 4 boxes, 10. That is for the x-axis. X-axis, I have 10 centimeter represent 1 unit. Yes, on the x-axis, I have this. Yeah, 10 centimeter represent 1 unit. Then we have on the y-axis, let me use, since I have all, look at the values, I have 3, 7, 13. Okay, I think let me take an interval of 2, 2, 2, 2, 2, 2. So let me still use 2, 2 box 6 here. So I have this place to be 2. I have this place 1, 2. I have this place to be 4. I have this place to be 6. I have this place to be 8. I have this place to be 10. I have this place to be 12. I have this place to be 14. So that line is 14. So that it can accommodate the 13th frequency. So I have the first information 0 to 9.5. Okay, so I can do this here. Permit me to do this. I have I told you 5 centimeter representing 1 unit, or 5 centimeter representing 10 units. 10 units, yes, for the x-axis. So which means 1, 2, 3, 4. Yeah. 1, 2, 3, 4. The first one here, you have this. 1, 2, 3, 4. The second one. So let me include here. This should be 9.5. This should be plus 10. This is 19.5. 1, 2, 3, 1, 2. Okay, coming. This is 19.5. 1, 2, 3, 4. This is 29.5. 1, 2, 3, 4. This is 39.5. And don't forget, the next one from 39.5 should have been 49.5. We have to be 59.5. So that I'm counting out my 8 boxes. 1, 2, 3, 4, 5, 6, 7, 8. So this will be, can have it this way. I have 59.5. So I have 59.5 there. So I can draw out this now. Please note that. And the first 0 to 9.5 is on 3, frequency 3. So I have frequency 3 here. This done. The next one, 9.5 to 19.5 onwards. 7. This is 7. So I have this. So what I have to do is this. Then I will clean this. Go back to this. Since we are dealing with 7, that's 7. Then the next one, 19.5 to 29.5, 13. That's 13. Right on this. This is 13. So 1, 2, 3, 4. Can you see that? 1, 2, 3, 4. This should have been here. Sorry about that. Mix up. So this should be 9.5. 29.5 rather. Sorry for there's a mistake there. So this should now be correct. So this should be 29.5. Oh, okay. So I maintain this, then I correct this. So this should be 29.5, which means this is where the error is. Four. So we have this should be of equal length, equal rectangular bars, though the length may differ. So we have the next one, 13. 13, 4. That's 13. Then the next one, 8 to 29.5 to 39.5. 8. 8 is here. 4. Good. Then we have the last, which is 39.5 to 59.5. 9.5. So this is 20 width. So it's taking like double of what the previous bars have been taking. So it's 10. Just up. 1, 2, 3, 4. 1, 2, 3, 4. Average. Can you see that? So good. We are good to go now. Now, the question is how you locate your median class. Don't forget the way we locate like from here, from this place. How do we locate our median class? Don't forget the formula that says the summation of f upon 2. And what would that be? Add all the frequency we have here together. We have 3 plus 7, that is 10. 10 plus 13, that is 23. 23 plus 8, that is 31. 31 plus 10, we have 41. So we are dealing with the whole frequency there is 41. So this should be 41 upon 2, and that should give me 20.5. It is a summation of f. But now we need to calculate for the cumulative frequency before the median class. Now, to locate the median class, 20.5, of course, where will that be? This is 10. This is 23. So the median class is here. So this is our median class. It is here. The median class has a frequency of 13, right? So now we go look at the cumulative frequency before the median class. That will be 3 plus 7, that is 10. So what do we do with that? We subtract that from the value for this. So we have, take note of what I'm doing, I have 20.5 minus 10, which is the cumulative frequency before the median class. That will give you what? That will give you 10.5. We have 10.5. We are not done. We come again. We come again. Now, you are not going to add, you are going to subtract the cumulative frequency of the median class. What's the cumulative frequency of the median class? This is the median class, right? The cumulative frequency at that point will be 3 plus 7, 10 plus 13, that is 23. So you write the 23. Then what do you subtract from it? You subtract the other value, which is 20.5. And what is 20.5? It is the value we use to locate the median class. So minus 20.5. So what do we have? That should be 2. That should give us 2.5. That is equal to 2.5. So this is what you are doing. This 10.5 and 2.5, let me indicate with something a bit sharp. So you have this 10.5 and this 2.5. We need both of them. So that's what, since I can identify my median class between 20 to 29. So this is a median class. This is the longest bar there in the median class. Now, what do we have for, yes, because it's our frequency 13, so the longest bar. So now we need to divide this bar into this ratio of 10.5 to 2.5. So we need the ratio of 10.5 to 2.5. That's what we divide this bar into, this bar. So what do we do? In the ratio, we know. How do we calculate this ratio? If we have something like this, we know that between 19.5 and 29.5, what do we have there? The value we have between that is basically, that is 10. Yes, that is 10. So we use it. That will be 10.5. Let's do it together. We have 10.5 upon 10.5 plus 2.5. 10.5, that will be 10.5 over plus 2.5. We have 13, then times 10. Why are we using 10? The class size is 10. So we have 10.5 times 10, that is 105 divided by 13. So that will give me approximately, we have 8 there. So that gave me 8. Then the other one will give me what? The first one is giving me 8. Let me write it under 8. I have 8 under this. 8. Let's check what this will give me. The other one will give me 2.5 upon 13 times 10. That is 25 divided by 13. So I have 1.9, and that is approximately 2. So which implies the ratio will be 8 to 2. We're dividing this into 8 to 2, 8 ratio 2. By the time we divide this box or this rectangular bar into 8 ratio 2, that means you are looking for 8 lines. because you will not see it here. From wherever between 19.5 and 29.5, count 8 lines, whatever you have taken your values to be. Normally it should be 10. Yes, between 19.5 and 29.5 is 10. So this will be 8. So let me just allocate this to be my 8. So what do we have? 8 to 2. Let me clean this. This is 8 to 2. So that implies I can pick this as 8. Do you see that? So it means my median will now be 19.5. Median will be equal to 19.5 plus 8. What is 19.5 plus 8? 19.5 plus 8. I have 27.5. So I have 27.5. And the question says calculate correct to the nearest whole number. So to the nearest whole number now, that will be 28. So my median is 28. I want to believe you understand that. Good. Let's now deal with the mode. From the same charts, let's calculate the mode. What will be the mode? Now, there's a principle for calculating the mode. Let me just show you. All you have to do is this. The bar before the longest bar. Check the bar with the highest frequency. Then pick this bar. This is a very short cut, so let's just learn that. You get that will help you to estimate the mode. This, this. Then these two, we go this, this. So wherever they meet, you calculate that out. I don't want to use red again. I have somewhere here. And by my calculation, that region, the mode there should be, let me say 19.5 plus, it's around 5.5. So I have 19.5 plus 5.5. What will I have? 19.5 plus 5.5. I have 25. If I even use 5, 19.5 plus 5, that is 24.5. But I'm picking 5.5. That is the perfect, because I've done this in a sketch of paper before now. So I have 25. So mode, let me write this in full. Mean. So the modal score of this whole distribution be equal to 25, as we rightly deduce from here. Even if I've used 24.5, approximately say to the nearest whole number will be 25. We are still correct. You see the beauty of this graph? So thank you for joining me. Please endeavor to subscribe to my channel. Endeavor to subscribe to this channel. And in the next video, we'll be doing something a bit different. So thank you. See you some other time.